So here I'm going to do a problem about albedo. So it has been estimated that doubling the amount of carbon dioxide in the Earth's atmosphere changes the albedo of the Earth by 0.01. Use the data given to show that this doubling will lead to a change of about 3 watts per meter squared in the intensity being reflected by the Earth into space. So the average intensity received to Earth from the Sun is 340 watts per meter squared, and the average albedo is 0.30. So, albedo is the fraction of energy received by a surface that gets reflected. So the mirror, because you can see yourself completely, has almost 100% albedo, which would make sense. And then on the other hand, the Earth has about 30%, because 30% of energy received from the Sun is reflected and not absorbed. So albedo is basically just looking at reflecting power. So this question is telling us that if we double the amount of albedo changes by 0.01, it'll lead to a change of about 3 watts per meter squared in the intensity, and we're here to prove that. So, let's just highlight the important numbers, because we're going to come back and use those to solve the problem. So, we're going to start with the power reflected. The change is going to be the original power times the albedo in the beginning minus the original power times the new albedo, which is going to be the same albedo in the beginning plus the change in albedo of 0.01, so over there. So then you can cancel these out, and don't worry about the sign, that doesn't matter in this calculation. So we're going to have the original power times 0.01 is going to be your change in intensity being reflected by the Earth into space. And then you're going to plug in the 340 given for the original, and you're going to have 0.01 there as well. So then that's going to equal 3.4 watts per meter squared. And that is telling us that the doubling will lead to a change of about 3 watts per meter squared. In this case, it's 3.4, but it's about 3 in the intensity being reflected by the Earth into space. So, yeah.